Hello everyone. In this video we are going to discuss vector addition in a more analytical method. We have already discussed vector addition in three different forms. One is triangle law, another is parallelogram law, and the third one was polygon law of vector addition. But we actually are now going to find what is the magnitude and the direction of the resultant vector. Till now in these three laws we have discussed and we have seen that how a resultant can be represented out of two vectors. But now we are actually going to calculate the length or the magnitude of the resultant and also the direction. Because we all know when we say a vector quantity which is represented by a vector, suppose the resultant of two vectors A and B is represented by a vector R. Now, when we say vector R, it has a magnitude as well as direction also. Till now we have not discussed in the previous videos that what is the magnitude of that vector. So, and also we have not discussed the direction. So in this video we are going to discuss both the magnitude and the direction of the resultant. So let us see how it is done. This is the analytical method of vector addition, where exactly we are going to find the length of the resultant vector and also the direction of the resultant vector. Because whenever we say vector, we need to know its magnitude as well as its direction. So that's what we are going to do now. Suppose two vectors are given to you. One is vector A, another is vector B, as you can see here. Like these two vectors are taken as the two adjacent sides of a triangle such that they are in the same order. They are represented both in magnitude and direction in the same order by the two sides of a triangle, vector A and vector B. Then the resultant is given by the remaining side, that is the third side of the triangle, but taken in the opposite order. The representation of the resultant is given by vector R, which is equal to vector A plus vector B. Now, this is only a representation. You need to understand it very clearly that the resultant vector R is the resultant of two vectors, vector A and vector B. But from this equation, we don't get the actual length of R, actual length of the resultant vector. We don't even get the direction of the resultant vector. It is just a representation. So we have done triangle law of vector addition, but it was the representation of the resultant vector of vector A and vector B. Now let us see how we can calculate the magnitude. So from the point Q, we have a triangle here which two sides are vector A and vector B, OP and PQ, and the resultant is given by OQ, which is vector R. Now from P we will drop a perpendicular which meets OP at point N. So at point N it makes an angle of 90 degree. So the two lines here, QN and PN, they makes an angle of 90 degree here. Now what we are going to do is angle QPN, this angle QPN, this is actually the angle between vector A and vector B. Always remember, whenever we decide the angle between two vectors, it is the angle between their directions. You can see here vector A is in this direction. So let me show you with the marker pen. Vector A is in this direction and vector B is in this direction. So they make an angle. The angle between them, between vector A and vector B, is theta. So never get confused with the fact that how to find the direction between angle between vector A and B. So theta is the angle between vector A and B. Now here we are getting a right angle triangle which is given by QPN. In this right angle triangle, the angle QPN is the angle between the two vectors, which is given by theta. OP, the length of the distance between O to P, that is the length of the vector A, is given by A, that is the magnitude of vector A. Similarly, PQ, the length of vector B, which is given by B only. And OQ, the resultant vector R, has a magnitude of R only, so OQ represents the resultant, and we are actually going to calculate the value of this magnitude R. So let us see how it is done. First of all, we consider the triangle QNP. This is a right angle triangle. In this right angle triangle, if we take sine theta is the perpendicular by hypotenuse or opposite by hypotenuse, which is QN by PQ. So you write here QN by PQ is equal to sine theta. So from this, the value of QN can be given by PQ sine theta, and PQ is B, so we can write Q1, which is equal to PQ sine theta, is equal to B sine theta. So this value of Q1, this Q1, we have calculated the value of this Q1, and it is B sine theta. Now for cos theta, if we want to write cos theta, it is Pn by PQ. So the value of Pn will be given by PQ cos theta. You can see here, we have written here Pn by PQ is equal to cos theta. So the value of Pn will be PQ cos theta, and PQ is PQ is B. So it is B cos theta. So B cos theta and B sine theta represents Pn and Qn respectively. This Pn, we have calculated it to be B cos theta. So we have calculated Qn, which is B sine theta, and Pn, which is B cos theta. Okay. Now what we actually are willing to find is the value of, that is the magnitude of R we need to calculate. So now we will use the Pythagoras theorem in the triangle ONQ. This whole triangle we are considering, this is a right angle triangle. So if we take the Pythagoras theorem, OQ square, hypotenuse square is equal to sum of the side square, that is ON square plus QN square. Now the value of ON is OP plus PN. So we write OP plus PN whole square plus QN square. Now let us put the values here. This OQ is the magnitude of the resultant, which is given by R. So it is R square is equal to OP. OP is A, so it is A here. Pn we have just now calculated, it is B cos theta whole square, plus Qn is B sin theta and this whole square. So it is, if we this is in the form of A plus B whole square, so we expand it, A square plus B square cos square theta plus 2AB, here it is 2AB cos theta, plus this square we are taking, so B square sin square theta. Now you can see here we have written A square, then for B square cos square theta, and we have another term with B square sin square theta. So B square if we take as common, so it is cos square theta plus sin square theta, and this 2AB cos theta is left out, so we put here. So we know the identity cos square theta plus sin square theta is 1, so it becomes A square plus B square plus 2AB cos theta. This is the value of R square, that is the magnitude of resultant and the square of it. So naturally the value of the resultant now will be given by root over, we have to take the root because it was the square term. So the value which we are getting here is, you can see here, it is root over A square plus B square plus 2AB cos theta. This is very, very important relation, and in the highest classes also you will be using this relation time and again. Whenever you are given two vectors and you have to find the resultant, magnitude of the resultant, the formula that you will be using is root over A square plus B square plus 2AB cos theta, where theta is the angle between the two vectors. So till now I think everything is clear, there should not be any doubt. Now see here, when we consider a vector quantity, the resultant vector is given by vector R. So we have calculated the length of vector r, that is the magnitude of vector r, which is given by root over a square plus b square plus 2ab cos theta. Now we need to find the direction. Now always remember, whenever we locate a direction, it is with respect to a known direction. That is, vector a is known, so we need to find the vector direction of vector r, that is the resultant vector r. So we say that this angle beta, that the resultant r makes an angle beta with vector a. So if someone asks you that what is the direction of the resultant vector, so you have to say it makes an angle beta with vector a, not with vector b. It makes an angle with vector a. So that is how you have to tell the direction of the resultant vector in terms of the direction of vector a. So let us see how to calculate the value of vector b. So to calculate the value of vector v, we will take tangent beta. In the right angle triangle, that is QON, in this right angle triangle, if we take tangent beta, to tangent beta it is perpendicular by base or opposite by adjacent, that is QN by ON. Now this ON can be written as OP plus PN, so we have written here OP plus PN. Now QN we have already mentioned in the previous slide. QN is represented by b sine theta, and in the denominator OP is the magnitude of vector A, and Pn is the magnitude, it is represented by b cos theta. So instead of Pn we will be writing here b cos theta. So tangent beta or tan beta is equal to b sine theta divided by a plus b cos theta. So that's how we calculate the value of beta. So the value of beta will be given by tan inverse, you can write here tan inverse, that is 10 raised to the power minus 1, tan inverse b sine theta by a plus b cos theta. Now always you need to remember one thing, the angle beta, whatever angle we are taking here, in the numerator the side we will be taking will be the opposite to that of the angle beta. That is, if suppose here, if instead of vector a, if we write vector b here and this is vector a, then tangent beta will be given by a sine theta by b plus a cos theta. So you need to understand that here the vector a is there and beta makes an angle, it is the angle between vector a and the resultant. So tangent beta will be given by b sine theta by a plus b cos theta. So I hope that I have made myself clear, but still then if there is any doubt, you are reluctant, you can just post me the doubts and it will be taken care of.